We're constantly asking AI to find stuff for us. But what if it could do more than just, find facts? What if it could do real research? We are on the edge of a massive leap, moving way beyond simple search engines to these powerful, autonomous research agents.
And that really gets to the heart of what we're talking about today. I mean, finding the capital of France? That's one thing. But can an AI pull together information from dozens of different sources, actually spot patterns, and come up with a genuinely new insight? That's the huge gap between just fetching information and conducting actual serious research. And this distinction is so important. A new paper from a company called StepFun puts it perfectly. Search is not research. Think about it. Searching is a transaction. You ask, it finds. It's kind of like a librarian's assistant who can run and grab any book you ask for. But research, that's a whole different ballgame. It's a creative process. It's about connecting dots, checking your sources, and building a solid argument. A lot more like a PhD student trying to write a thesis that changes everything. So how in the world do you teach an AI to be a researcher instead of just a searcher? Well, that's the exact puzzle the team at StepFun decided to crack with their new model, which they call Step-DeepResearch. And their core idea? It's honestly brilliant in how simple it is. You have to break down the super complex skill of research into its most basic, fundamental parts. They gave these parts a pretty cool name, atomic capabilities. Now, don't think of these as tiny little actions like click a link. Nope, these are the big picture, high-level skills that any human researcher absolutely needs to master. It's about teaching the AI how to think, not just telling it what to do next. Okay, so check this out. Here are the 4 core atomic capabilities they zeroed in on. First, planning and breaking a huge question down into smaller, manageable chunks. Second, deep information seeking, so going way beyond the first page of Google results. Third, and this one is so crucial, reflection and verification, fact-checking and catching its own mistakes. And finally, reporting, organizing everything it found into a document that actually makes sense. It's kind of like teaching a chef how to use a knife and make a perfect sauce before you'd ever expect them to invent a brand new dish.
Okay, so you've got the skills defined, but how do you actually teach them to an AI? You need tons of high-quality examples, but trying to record expert researchers in action is, well, super difficult and crazy expensive. So the StepFun team came up with a really, really clever workaround.
And this quote right here, this is the secret sauce to their whole strategy. Instead of trying to create brand new research examples from scratch, they started with the finished product. They took existing expert-written documents, things like technical reports and scientific papers, which are basically perfect examples of what the end result of a complex research task should look like. They call this their reverse engineering strategy, and it's kind of like looking at a perfectly baked cake and using an AI to figure out what the original recipe must have been. They take an expert report, use another AI to guess the original question that prompted it, and then, get this, the report's own table of contents becomes the perfect step-by-step plan for how to answer that question. And just like that, boom, they generated a massive data set of top-tier, expert-level training examples without breaking the bank. So, using all this amazing data, they built a 3-stage training process. In stage 1, agentic mid-training, the model just learns those individual atomic capabilities, the basic moves. Then, in stage 2, supervised fine-tuning, it learns how to chain all those skills together to finish a whole research project. And finally, stage 3, reinforcement learning, where the AI is basically let loose in a real-world setting to practice, get feedback, and just get better through good old trial and error.
All right, so the theory is cool, the training method is super clever, but did it actually work? How did this StepDeepResearch model stack up against the biggest names in the game? Let's take a look. So take a look at this chart. This tells the whole story. On the vertical axis, you've got performance. Higher is better. On the horizontal axis, you've got cost. Lower is better. You can see all the big players kind of clustered together over there. And then look way up in that top left corner. That's StepDeepResearch. It's hitting a performance level that's right up there with the best of the best, but at a tiny fraction of the cost. Let's zoom in on those performance scores. So StepDeepResearch, which is a 32 billion parameter model, and you can just think of parameters as a rough measure of a model's size, it scores a 61.42. That is neck and neck with systems from Gemini and OpenAI, which are almost certainly way, way bigger and more complex. It's punching way above its weight class. But here's the real kicker, the cost. The average cost to have StepDeepResearch generate one of these super detailed reports is less than half a yuan. For comparison, the paper estimates that for its top competitors, you're looking at over 5, maybe even 6 yuan per report. That is more than 10 times the price for basically the same quality. I mean, that's a game-changing difference. So let's zoom out. What's the big picture here? What do these honestly incredible results really mean for where AI is headed?
And really, the key takeaway here throws a wrench in the whole bigger is better idea we've been hearing about in AI. This isn't just about building bigger and bigger models that eat up more and more data and energy. This research proves that smarter, more creative, more targeted ways of training can let smaller, much more efficient models perform at an absolutely elite level. And look, this isn't just some academic exercise. This matters for all of us. It makes these incredibly powerful research tools accessible to way more people and companies by slashing the cost. It challenges that bigger is better arms race, which opens the door for smaller, scrappier teams to innovate and actually compete with the industry giants. It's a fundamental shift in how we think about building smart AI.
So it all leaves us with this one big question to chew on. Is the future of AI really just a brute force race to build the biggest models we can possibly imagine? Or is the real frontier in discovering these clever, efficient, and targeted ways to actually teach these models how to think, how to reason, and how to create? This work from StepFun, well, it suggests it's very much the latter.